two equations with two variables, you know, we're talking about just having an x and a y-axis, graphing those lines, checking to see where they cross. Even when we did the quadratic and linear system, we still were just dealing with like an x-y type of situation, like where it was just an x-axis and a y-axis, seeing where everything crossed. But now that you're going to have three variables with three equations, you're looking at something that's more like three-dimensional. So that's why they have these pictures shown here. There's an example down here at the bottom of what this is going to look like. So this right here, this top section, this is a 3x3 system. Okay, don't pay attention to what's underneath it just yet. But you guys are going to be given three equations that will have three letters. So most of the time we use X, Y, Z. It could be A, B, C, R, S, T, it doesn't matter. And we are going to solve for all three variables. And there are different ways of doing it. We can use substitution. We can use elimination. I'm going to show you examples of both. But the kind that you're going to end up practicing today is mostly elimination for the most part, okay? This one over here has already told you what the answer is. So they wrote their answer like this. It almost looks like an ordered pair, but since now we're dealing with three variables, it's X, Y, Z. It's called, they wrote ordered triple. I've also heard it called ordered triplet. Either way, it just means that you're dealing with three coordinates instead of just two. Okay, so if we know that this is X, this is Y, this is Z, they're just showing you that no matter which one of these equations, like if I numbered them 1, 2, 3, if I plugged these three numbers in to the first equation, X would be replaced with the 2, the Y would be replaced with the -1, and the Z would be replaced with 1. So look at what they get. 2 plus -2 minus 3, and they get an answer of -3, which is what it said we would get. So I know if I plug this ordered triple into this, I get the right answer. If I plug it into equation 2, it's also going to work. And then if I plug it into equation 3, all three of these numbers plugged in do give us that answer of 5 like they said it would. Okay, so in order for this triple, the ordered triple or triplet, to be the solution to the system, it has to be true with all three equations. Okay, now I'm not going to have you guys do that. What you guys are going to do is you're going to be given three equations and we're going to solve for our final ordered triplet. But I'm just showing you, like, when you get your solution, no matter what equation you plugged all three numbers into, they'd all be true. Okay, that's the whole point of solving a system. Okay, so go ahead and turn the page. This first example is the hardest one, and it's using substitution. Now, you will not be practicing any like this today on your practice page. That doesn't mean you might not see one pop up on your test. But we're going to talk about substitution. So remember when I said yesterday, if one equation had a variable by itself, that's the one you used for substitution. So look at this top equation. See how the x is completely by itself? Okay, put a box around this. Put a box around the y plus z. What that means is wherever I see the letter x in each equation, I could take the x out and put this in its place, right? Yeah. Okay, so over here to the side, I want you guys to do that. I want you to put the negative sign. And then if we are replacing x with this expression, we'd put y plus z in the parentheses. And then just copy the rest of the equation down. Plus 2y minus z equals 14. It's a z.
Okay.
Well, we're gonna simplify this one first, and then we'll do it down here too. Okay. All right. So if you have a negative sign in front of parentheses, doesn't that technically mean a -1? So can't I just distribute here? Okay. So let's do that. -1 times y. Or -1y, either way. You don't have to put the 1, but you have to have the negative and the y. And then -1z, right? And then just copy the rest of it down. I'm just simplifying this equation. Okay, do we have any like terms that we could put together? We have -1y plus 2y, which would make it 1y, yep. And then -1z with another -1z is -2z, and then equals 14. Now I can't do anything else, right? Because we still have a y and a z. So for right now, let's leave this alone. And I want to do this same process with this equation. So remember how we can take the x out and put this in its place? Let's do that with this equation. So -6, and then in parentheses put y plus z, and then copy the rest of the equation down. Distribute that -6 for me. What would I get? -6y minus 6z, good. And then just copy the rest of it down. Then combine our like terms. So -6y plus 2y is -4y. And then a -6z with a -1z is -7z equals -11. Okay, so now that equation is as simplified as we can make it, correct? Okay. Here's the good news. We no longer have x, we just have y and z. If both of these equations have y's and z's, can't we pair them up and try to eliminate either the y or the z? Yeah. So now we could use elimination. So even though in the beginning we used substitution, I'm still going to end up using elimination. I'm going to bring, it's really important on these problems to be as neat and organized as you can be. I'm going to bring this one, I'm going to bring it over here. And I'm just going to line these up with each other. And then we need to come up with a plan to get either these two y's or these two z's to cancel. What could we multiply the top equation by to cancel out something with the bottom equation? Not a -4. +4. Yeah, so look, we could multiply this entire top equation by 4. You guys all still with me? Because there's a lot of stuff up there already. And look, watch what I'm going to do. Yesterday, remember how I drew it and wrote it next to it? I'm going to write it underneath this, so that way it's lined up with the other one. 4 times 1y is 4y. What is 4 times a -2z? -8z. And then 4 times 14. Not negative. It's just 4 times 14. It's just 56. All right. Now, if we put, so up on the screen, I could put this red and purple equation together. Y's disappear. And let's solve for z. What's negative 7 minus 8? Negative 15z equals, and then what's negative 11 plus 56? You got a negative and a positive. It's 45. Now we can divide, and we'll have z. Yep. Now I'm going to kind of contradict myself, because remember yesterday, I can't even remember who asked. It might have been Brittany, but somebody had asked, do you always have to plug it back into an original equation? And I said yes. Okay, well here's the thing. I only have one answer right now. If I were to plug this into any of these equations, we'd still have 2 letters left, wouldn't we? So could I plug it into one of these 2, like that I drew the blue box around? Like if I plugged it into this one, couldn't I solve for y? Yeah. So let's do that. I mean, we don't really have a choice today. Like yesterday, we plugged it back into the original because there were only 2 letters. But when there are 3, sometimes, once you get your first answer, sometimes you just have to plug it into one of the ones that we got along the way. So I'm going to I could plug it into this one or this one, whichever one you guys thought was easier. I'm just going to go with this one because I actually have room underneath it. But does it really matter which one you plug it into? No. So I'm going to take negative 3. And I'm going to plug it in right here where that z was. So we're doing substitution again. We're like going back and forth between, we're going to do substitution, eliminate. Then we might have to substitute, and then we just keep going. It's a lot of work. And if you are somebody who writes super messy and kind of all over the place, might be kind of difficult to follow all this, especially while you're doing your own. So try to take your time and try to be like neat. Okay, I multiplied these 2 together, giving me a positive 21. And then what do I do next? Yep, so I have minus 21. So I have negative 4y equals negative 32, and we would just divide, and then we finally have y. So y equals 8. Okay, the last one's the easiest one to do. Oh, I'm not moving. Because right now we have y and z. X is going to be the easiest one to find. So we've done all the hard work. Look back at your 3 original equations. Look at that top equation. Doesn't it say x equals y plus z? And we have y and z. So if we just add these 2 together, won't we get x? So we're now using substitution again. We're going to take, so this is the final piece here. I keep trying to use different colors so you guys can kind of see all the different steps that I'm doing. My final piece is taking the original top equation that said x equals y plus z, and I now have a number to plug in for both y and z. X equals 8 plus negative 3, which is 5. Okay, we have all 3 of our answers. Final answer has to be written in parentheses, right? So it's kind of like an ordered pair, but there will be 3 numbers. And just put it in alphabetical order. So we know in the alphabet it goes X, Y, Z, right? 5, comma, 8, comma, negative 3. Yep. 5, comma, 8, comma, negative 3. Yeah. Now, that is a huge problem. I mean, that's half the page. I wasn't lying when I said when you do 3 equations, 3 letters. So it's not that difficult. It's really not. Like, you guys are all capable of doing that, and especially like as we work it out together, you're able to figure it out. But it is a lot of work, and if we had messed up anywhere along the way,
I would cry.
this is what potentially happens. I'm not going to give you problems where you guys are getting decimal answers. So if at any point you get a decimal, stop. And then like ask me like, hey, I got a decimal, I messed up somewhere. I can usually find your mistake pretty quick. A lot of times it's signs. So just take your time, try to do this the best that you can. Now, I told you, you're not going to have one set up like this on your practice page today, but that doesn't mean that you won't ever see one like that. Okay? The ones that you're going to see more of are the 2 that we're about to do. You guys are going to like this one. This one is so much easier. Okay, now look. All 3 equations are set up like standard form, right? X, Y, Z, X, Y, Z, and they're all nice and lined up. However, you are never allowed to pair 3 equations up at a time. You can only pair up 2 at a time. So what I'd like you guys to do, look at 2 equations and see if there are 2 equations that if we put them together, 2 letters disappear. The first 2. Look at what happens with these top 2. Now, I don't know, whatever you need to do to not look at that bottom one, cover it up with an extra pencil or something. Look at what happens. What's going to happen with the X's? They're going to go away, and so are the Z's, aren't they? So all you guys have to do is add your Y's and add your constants. So we can add, it's better to use pencil. I know I'm using pen, but like you'll have to refer back to these. So if you're using pencil, I'll probably have you erase that stuff eventually. I'm just not going to be able to. Okay, so 6y,
Yep.
right, equals
Negative 18.
-18. Now look, we're already going to have our first answer. If we divide by 6, what's our first answer?
3.
-3. So much easier. Okay, so now what you guys probably would want to do is using your pencil, I'd go over here and erase this stuff that you drew, because now what I want you to do, if we've already paired up the top 2 equations, are there 2 other equations like top and bottom or bottom 2 that we could pair up and 2 other letters cancel?
Yes.
Yes.
Which ones?
The second and third one and the Y.
Okay, so second and third, I'm going to just use a different color. Actually, I'm going to highlight so I can, this stands out a little better to you guys. Okay, so I'm going to pair up these bottom 2. And when I do that, the Y's disappear and the Z's disappear. So we're going to add our X's and we're going to add our constants. So -2x with a -3x.
-5x
Perfect.
equals,
And then -8 with a -17.
Negative 25.
-25. What? Somebody yelled out an answer before you for once?
Oh my god.
Okay, now what do we do? Divide?
Divide by 5, -5, which will be x equals -5.
Positive 5. Okay, so good news. Getting the first 2 answers, really not that complicated, right? Now the third answer, we don't have a choice. We have to do plug and chug. Now here's the good news. Do we all have to plug it into the same equation? No, you guys have 3 choices. We have X and we have Y. We still need Z. So we could all plug it into the top. We could plug it into the middle. We could plug it into the bottom. I mean, you know how I am. I'm going to end up going right up here to the top and plugging it into that equation because that's just typically what I do. That doesn't mean that that's the best way. You know, I don't look to see, oh, which equation's going to be easiest. I just do it. So next to the 2 goes the 5. Next to the plus 5 would go the negative 3. And then plus 5z stays the same, equals negative 10. Once we simplify all that and solve for z, we'll be done with this problem. So this one took a lot less work. What is 2 times 5?
10.
And then 5 times negative 3. Okay, hang on. Look, watch the board. 10 minus 15 here, which gives me negative 5. Now all of this has been simplified, right? So I can just bring down the plus 5z and the equals negative 10. And then that's a 2-step equation for you guys to finish. Oh good, my headache's going away.
That's good.
Yeah,
I think it was the earlier class.
that's, yes, you're right. Okay, so plus 5. I had some sugar at lunch, and that probably was a bad idea. It always ends up giving me a headache. Negative 10 plus 5,
Negative 5.
negative 5. And then we're going to finish with division.
Z equals negative 1.
So we're going to divide by positive 5, giving us z equals negative 1. I hope you guys liked that one a lot better. Yeah, if you just look at the top half of your paper and then look at the bottom half, there's so much extra space at the bottom, which is really nice. But let's write our final answer. Our ordered
5, negative
triplet.
3, negative 10.
Yeah, so just make sure you go back to putting it in alphabetical order. So x was 5, y was negative 3, and z was negative 1. Okay, you guys good with that one?
Yep.
Caleb, where do you need to see? The bottom? You need to see that still?
Yeah.
Okay, you're welcome. Okay, did you write your triplet? Did you write this?
Yeah.
Okay, last problem here, and then, I mean, there is one down at the bottom that we'll talk about, just to see what you guys think. All right, now this one. First equation has 3 letters. Second equation has 3 letters, but that last one only has 2. You want to know why I really like this problem? Because remember back here, I asked you guys to find 2 equations to pair together, and you had different options because you could do top, middle, middle, bottom, or top and bottom. Well, over here, if 2 equations have 3 letters and one has 2, am I allowed to pair this one up with either of those? They have to have the same amount of letters. So you guys don't even have a choice. Like if I said to you right now, which 2 equations could we pair together? I don't have to wait for, Matt to say, well, let's do top and middle, or somebody else to say, let's do middle and bottom, because there's only 2 that we can actually put together right now. Which 2? The top and the middle, right? The ones that have 3 letters are the only ones we can put together. So you don't even have to sit here and think about it too much. You're just like, okay, well, These are the only two that have 3 letters, so I guess that's where I'm starting. What happens when we put those two together? What falls off?
X.
Just the x's. Okay, but that's okay. So if it's just the x's, add these two, and add these two. So what's 6y minus 4y? 2y. What's 4z plus 1z? 5z equals, and then what's 26 minus 8? 18. Okay, now, have no fear,
Superman.
because there's 2 letters here that just so happen to be the same 2 letters that these two had. So can't I pair these two up now? Because you can only pair an equation with 2 letters with another equation that has 2 letters. So I get to bring this guy over here, pair them up, and not only that, but what happens when we pair them up? No, they both don't cancel. It's just the y's. Remember, their signs have to be opposite for them to cancel. So the y's will cancel. We can add our z's, and we can add our constants, and we have our first answer. Well, I heard a 40 over here. And then?
5z divided by 5.
No, 5 and 5 makes 10.
5e.
You've got to add the 5 z's together. Don't forget to do that part. That's why I keep circling stuff, because sometimes you guys overlook numbers. So if we divide by 10, z is 4. It's okay. Well, now hang on. So watch. After I have my first answer, there's nothing I can pair up over here different. Like, I paired up all I could pair up with. But one of the original equations only had 2 letters. Remember this equation right here? It only had a y and a z. Well, what did we just find? So can't we plug that in and find y?
Yeah.
Let's do it. So we're going to plug this in right where that z is. You'd have negative 2y plus 5, and then insert that 4 next to the 5. Okay, what's 5 times 4? Okay, 20. And then you just have a nice 2-step equation. We're going to subtract and divide, right? So negative 2y equals 2.
Divide by negative 2 and get y equals 1.
So we divide by negative 2 and we get y equals negative 1. Okay, so now we have y and z. We still need x. Okay, so now once we knew z, there was only one equation we could plug it into. It was this one, the one that only had 2 letters, right? Well, now that we have 2 of our answers, couldn't we plug it into the top or the middle equation?
Yeah.
Okay, I'm just going to stick with my habit here. So I'm going to plug it into that top equation. I honestly think the bottom equation would be easier, but I just, you know, I like to stay consistent. That's what I like to do. I don't like to keep changing stuff up all the time. Creature of habit I am. Okay, so this, can everybody, like, is everybody good doing this? I don't know if you need to watch me set it up, but I'm going to take this equation and I'm going to leave the negative 4x the same. Then I'm going to put plus 6, but then instead of putting the letter y, I'm going to put in that negative 1 that we just found. And then plus 4, and then instead of putting the letter z, 4 equals 26. I believe you, but you're way far ahead of me. So I need to simplify this stuff right here. So I've got 6 times -1, which is -6. 4 times 4 is 16. And -6 plus 16, 10. So then, like, I like to scratch out stuff I don't need, because the more stuff I see, the more confusing it gets. I can bring down that -4x plus, and then the 26.
Subtract them on both sides.
And then divide.
-4x equals 16. Then divide by -4 on both sides.
Perfect. Good job. Yep. Okay, so if you guys could hear him, there we go. We got -4x equals 16. We divided by -4, giving us an answer of x equals -4. And then you've got all 3 numbers you need for your ordered triple or triplet. -4, -1, 4. X, Y, Z. There you go. Okay, once you guys have that one done, before we look at this last one, this example that we did up top, where there were 2 equations with 3 letters and 1 equation with 2 letters, you'll have some like that on your practice page, and then you'll have some like this example, where there were 3 equations with 3 letters. Those are the only 2 type that you're going to practice today. I'm not moving it. I'm just putting it back where it was. There you go. On the bottom. So can you see mine? This is the end of it right there. Okay. What I'd like you guys to do is I just want you to, while Caleb's finishing that up, look at that bottom problem. The question says, which method do you think would be the best to use, elimination or substitution, and why? What does that very top equation say?
X equals 3.
So don't they give you a number to plug in?
Yeah.
So isn't that substitution?
Yeah.
Okay, so we are going to end up using substitution down there at the bottom. We're going to end up plugging that 3 in to that second equation, because look at your second equation. Doesn't it just have x and y?
Yeah.
So if we plug that 3 in where the x is, can't we solve for y?
Yeah.
Okay, so while Caleb's finishing, can you guys start that problem for me?
I can get it done for you.
Well, okay, if you can, do it, but don't be shouting out answers. I just like you to get it started, and then when I move it up, I'll work it out. And this really is the last problem we're doing.
What about that back?
We're not doing anything on the back.
Okay. Got it.
I'm just not going to pull up like that website, and you guys can always try some of that on your own. I think it's it has a website on there that you can go to, and it's like a 3D grapher, and they'll have you plug some stuff in to graph, and you can actually see what it would look like. All right, so down here at the bottom, I'm going to take 3, and I'm going to plug it into that second equation where the x is. So I'd have 2 times 3 plus y equals 12. What's 2 plus 3? Did I just say 2 plus 3?
Yeah.
2 times 3 is 6. Yeah, I said it wrong. You said it right. I don't know what I was thinking. And then how do I solve for y?
Subtract 6.
Yep, just subtract 6. So y equals 6. So we already have 2 of our answers. We have x, which is 3, and we have y, which is 6. So the only thing we're missing is z. And obviously, like, we only have this bottom equation that has a z in it. So clearly, that's the equation we're going to use to do our plug and chug, right? So we're going to take this. Okay, this negative sign right there, I'd have to put in front of the 3. Plus 2 times 6. And then plus 3z equals 21. Two times 6 is 12. And then when we put the negative 3 and the 12 together, we get 9. Subtract and divide, you should get 4. So I'm going to subtract 9, and we would get 3z equals 12, and then divide by 3. So that's where we get z equals 4, and once you have that one written down, just make sure you go back up here and plug that into your ordered triple. And then, like I said, they really have tried to incorporate a lot of technology into, like, the new curriculums. So if you guys turn the page over, you're going to see there is a website there if you guys ever have a chance or want to see what this kind of stuff would look like if you were to graph it. You can go to that website and then you can just follow those directions and rotate things, and you can see how everything would look in 3D with these types of problems. But that is the end of our lesson for today.